Hello, grade 9s. This is our lesson on polynomials called combining polynomials. So the first thing we have to remember is our algebra tiles. So just remembering that shaded tiles means it's positive, non-shaded tiles means negative. So for example, here's our tiles. We have an x squared positive tile. We have a negative x squared here. We have a positive x that looks like that. We have a negative x that looks like that. Positive 1 is like this, and negative 1 is like that. These we have to remember in order for us to be able to represent, which is a useful skill. Okay? So, before we continue, we also have to remember what zero pairs means. So, opposites are equal to 0 when they are combined. So, for example, a positive x squared and a negative x squared, when you put them together, they are a 0 because they cancel each other out. They're opposite. Same with a positive x and a negative x, they equal 0 when combined, and a positive 1 and a negative 1 will equal 0 when combined. All right, so remembering that, and especially what those tiles look like, we move on to, for example, a question that you'll have to do is represent each expression using the tiles and then simplify the expression. So negative 3x is the first thing we have to draw. So there's negative 3x's, looks like that. Now we draw positive 6, so there's 1, 2, 3, 4, 5, 6. And of course they're shaded in because they're positive 6. We have a positive 5x, so the x's look like bars again. 3, 4, and 5, all shaded in because they're positive. And I'm going very quickly here because I want to try to keep this nice and short. And finally, a positive 2. And again, shaded in. Okay, so now I look for 0 pairs. So for example, one of these and one of these cancel out, so we cancel them out. This and this cancel out, and this cancel out, right? Opposites will cancel. These ones and these ones won't because they're all positive. Now to simplify, we are just going to write down what we have left. Starting with our highest degree tile, the tiles with the highest degree are the x squareds, then the x's, and then the positive or negative ones. So this is higher degree. So we have 2x plus, there's 6 and 2 plus 8. That's simplified. Okay. So next one, we have 4x squareds. So that's an x squared, 2, 3, 4. And I'm going to very quickly here shade them in because I'm sure you get the idea. Then we have negative 5x, 1, 2, 3, 4, 5. We have a negative x squared, which is just an x that's not shaded, and we have negative 2x. All right, so there's our representing. Now I have to simplify. So opposites will cancel out, 0 pairs. So this one and this one. And that's all. There's nothing to cancel out. So starting with the highest degree, which is the squares, then these x's, there's no individual positives or negatives. So this one simplified, we have 3x squared or positive 3x squared, and negative, there's 5, 6, 7, negative 7x. And that is called being simplified. Okay. Last example with the tiles is this question here. So we have 2x squareds shaded in. We have negative 3x. We have positive 4 shaded in. We have negative 3x squareds, 1, 2, 3, all negative. We have negative 5, 1, 2, 3, 4, 5, and we have a positive x, which is a bar shaded in. So here's our expression represented. Now we look for 0 pairs, and there's a whole pile of them. We have this one and this one will cancel with these two, so they're 0. We have this guy and this guy here, these x, negative x and positive x canceling out. We have these 4 and 4 of these canceling out. And there's what we have left. So starting with the highest degree, which is this tile, then these ones, and then that one. So what we have left is a negative x squared, or a negative 1x squared. We then have these two, which are negative 2x. And then we have this one here, which is a negative 1. And that is our simplified expression. Now eventually what we want to do is we want to get away from the tiles, because this is all nice and dandy to be able to represent the expression and then simplify it visually. But we want to get away from that and go abstract. Abstract meaning without the use of tiles and just kind of doing it in a different way without concrete objects. So here we go. Simplify the expressions by grouping like terms. So we're going to start with the first one here. So we have 5x squared minus 2x plus 3 minus 12x plus 6x squared minus 6. So what I want to do is I want to use shapes like circles, squares, triangles, maybe underlining, and I want to group the terms, the families of polynomials that are the same. So for example, x squareds and x squared. So you notice I have 5x squared, I'm going to put a circle around it, and I look for any other x squareds in my polynomial. There we go, I have a 6, which I have to remember that it's positive, so I will group and I will circle the entire, this is called a term, I will circle the entire 6x, positive 6x squared term. And that's it. Now I look for other families that are similar, like the x family. I'll use a rectangle, combine that with the negative 12x. Those two are x families. These guys right here are the last. Maybe I'll just underline them. I can also put a triangle. So that's the last family of, those are the constants, the numbers that are all by themselves, not attached to a variable. And now I do this abstractly. So combining a 5x squared with a positive 6, 5 and positive 6 is 11, x squared. Now I combine my x's, negative 2 with a negative 12. So negative 2 added to a negative 12, combining is negative 14x. And finally we have a positive 3 with a negative 6. When you combine those, you get negative 3. And there is a simplified expression without using tiles. Okay, second example. So here we have x's and y's, x squareds, right? So I'm going to use circles for my x squareds, highest degree. The exponent is larger than the other, so I'll circle them, also making sure that I take the signs with the number. Now my x's. X's come before y's, so I'll do my x's next. X's and y's have the same degree. This has a degree of 1, so does the y. So I'll do my x's first. Then I'll just underline my y's. And now I'll simplify, starting with my x squareds. Negative 2 with a positive 8. When I combine these two, I get 6. Positive 6, or just 6x squared. Right? Now I'll add my x's. 5x with a negative 4x way over here. So 5, negative 4, when I add them, you get plus 1 or just plus x. Plus 1x or just x. Lastly, we have our y's. We have a negative 2 combined with a negative 5. That gives you negative 7y. And that is a simplified expression. Okay, lastly, last example. It's a doozy, it's a long one. If you can do this, you can probably do most of them. So let's look at, starting with our x squareds. So here we go. We will combine our negative 3 with our positive x squared, positive 1. We have, let's say our x's will be in boxes. Positive x, and here's a way over here. I've got my negative 3x. I still have y's and negative 4, so I'm going to use my triangle. So I'm going to put a triangle around my y's. And over here, there's my negative 5y and positive 7y. And finally, I will just underline my constant values, my numbers all alone. So I have 3 of them to combine. When I combine like terms, starting with my x squareds, I have negative 3, and this is a positive 1. Right? There's a coefficient of 1 here. So negative 3, positive 1, that's negative 2 x squared. Now combining our x's, we have positive x and negative 3x. So that's a positive 1 coefficient with a negative 3. That's negative 2x. Then we go to our y's. We have positive 7y, negative 5y. So that's positive 2y. And finally, we have our constants. Negative 9, negative 4, positive 6 is a negative 7. Simplified, this expression is negative 2x squared minus 2x plus 2y minus 7. And that, grade 9s, is our lesson on combining polynomials. I sure hope that helps you, and good luck in the rest of your math journeys.